How you doing, guys? We're here for another lesson number 8. This topic is simplifying radical expressions. Now, the most important thing that you guys are going to have to do from this lesson is to make sure that your index matches your powers, okay? So right here, the key to this lesson, make sure that your index, now if you remember your index, that was the letter N, okay? Your index matches your power. Matches your power. Okay, so index must match your power. That's the letter P. In other words, N must equal P. If N equals P, then the radical disappears. Remember, we talked about that before. Okay, so that's one of our keys here to try to get that to happen. So we'll start off with some examples here. And as usual, we start easy and try to move on a little bit more difficult by every single example that I do. I try to make it a little bit more difficult every time. So let's start off with something like this: the square root of 80. Now, when we look at the square root of 80, we know that the index, I'm just going to kind of write this over here to the side, okay? The index is a 2, right? Because right here, there's no index. That means it must be a 2. So the index is a 2. That means that everything I need to do inside of that radical needs to have a power of 2, a square root, right? So in doing that, let me go ahead and break this down. I know that 80 is, what would that be? 16 times 5? 80 is 16 times 5. It's also 2 times 40. It's 4 times 10. But I always try to find a nice number that has a nice square root. Okay, now before I just take the square root of 16, I want to show you guys just one little extra step, okay? This is 4 squared times 5, okay? So 4 squared times 5. Now, if I may, I'm going to actually write in the index here just to make a point. Notice how the index and this power match. Therefore, the radical disappears for the 4. Now, it's going to stay there for the 5, but it's going to disappear for the 4. So we put 4 and then square root of 5, and that's going to be my solution. So 4 square root of 5. Okay, now some of you guys were just saying, well, Mr. V, I'd rather just take the square root of 16 and put that outside, and that would become a 4 just like you got. That's true, and you don't have to do what I just did. The reason why I did what I just did is because there's going to be some of these things that are going to have different index, and if the index is not just a 2, you may not know how to do it easily. So it's best if we kind of try doing it the way that might benefit you later. So let me give you an example of what I'm talking about in a bit. Okay, let me do one more easy type and then we'll move on. Okay, so again, for this one, the index is 2. And I know that the square root of 200 is the same as 2 times 100. I know a lot of you guys are going to say, oh, the square root of 100 is 10. Let's take it out. You can do that. I'm just going to take an extra step, okay, and write 2 times 10 squared. And just like I did in the other problem, I'm going to put in my index here, which is a 2, and then I'm going to kind of highlight, all right, since I have a 10 squared, that 10 is going to go outside, right? The radical is going to disappear for it. The radical 2 will still have one, okay? So this will still be 10 radical 2. Okay, now let's get to a problem, like I said, that might be a little bit more difficult. Not a whole bunch, but just a little bit more, okay? So moving on to part C. The 4th root of 96. So now we have to start thinking, okay, what is the 4th root of 96? Now, I have to find some number that multiplies times something else, but one of them, I can write it as a 4th power. Okay, so we're going to notice here that our index is a 4. Okay, our index is a 4. So just thinking about it a little bit, I can tell you that 16 times 6 is 96. And the reason why I chose 16 is because 16, I can write it as 2 to the 4th times 6. Okay, and actually, I can break down that 6 a little bit more into 2 to the 4th times 2 times 3. But you notice the 2 and the 3, they don't have a 4th power. There's no way I can make it into a 4th power. The only thing that has that 4th power is that 2 right there. So that 2 will come out. And what's left over is a 2 times 3. Because nothing can happen there. So it's just going to be 2. Oh, I'm sorry. I forgot to write 4th root of 6. So 2 4th root of 6. So you can kind of see why it's important for us to be able to write this out into the correct powers. Okay. Now I'm going to do one more that I would kind of consider a little bit on the easier side. Then we're going to move to some harder stuff. Okay. So here's part D. So the 4th root of y to the 6th. Now, notice y to the 6th, that's the power on the 6. On the y is a 6, and the power on the index is a 4, right? So let me write right here. The index, just as reference, is a 4. So what I'm going to do is I'm going to break down that y to the 6th into y to the 4 powers as much as I can. So y to the 6th, that's the same as y to the 4th times y squared. Now notice, now I have matching pieces, right? And that y squared is never going to become a y to the 4th. It doesn't have enough y's in there. So that means I can take out one y and leave the 4th root of y squared inside. So there we go. There's part D. Now maybe you don't think that's hard, and if you don't, that's great. All right, let's do another one that's kind of like this. So part E, we're going to do the square root of 8x to the 14th. Okay, now I'm going to show you guys a nice little trick for this. Okay, so, and it's not so much a trick, it's just using a property, because x to the 14th, that's a lot. Okay, that's a lot of things. So I'm going to show you how to do it the long way and the short way. Okay, so again, our index is a 2. Okay, there's a little 2 right there. So I break down 8, and now first I'm going to show you the long way. Okay, I break down 8 into 4 times 2. And then x to the 14th, I'm going to write it x squared times 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 x squared. 1, 2, 3, 4, 5, 6 times x squared. Like I said, this is a long way. Okay, so let me erase this and do one continuous line here. Now, this power here. Okay, so notice that is x to the 14th, because that's x squared times 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 x squared. So if you add them all together, that's 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2, which is 14. That is the long way to do stuff. Okay, but it's not the wrong way in a sense, because let me just continue here, and then you guys can decide once I show you the shortcut what you want to do. So just give me a second here. I'm just trying to write this out. So, all right, since my index is a 2, then that means this matches that, and that, and that. So a 2 is going to come out. And then a total of 1, 2, 3, 4, 5, 6, 7 x's. That's x to the 7th. And the only thing left is this 2 in there. So it's going to be square root of 2. And that would be my answer. Now there is a faster way to do this. Okay? There is a faster way to do it. I'm going to do it in purple over here to the right side. So if you have the square root of 8 times x to the 14th, what I would do is I would still do 4 times 2, but x to the 14th, I would write it as x to the 7th squared. Okay, and if I can just take an extra step here, that's 2 squared times 2 x to the 7th squared. Now, since my index is a 2, right, then this matches that and that, which means that I can take out a 2. I can take out this 2. I can take out the x to the 7th. And the only thing left is that 2 there. So square root of 2. So you get the same answer. Okay? But without having to write so many terms. This process right here that I use, so this part right here, that came from this piece right here, that's called the powers of powers property. Okay, so powers of powers. All right, so let's do one that's a little bit more difficult than the one we just did, and we're going to try doing the shortcut so we can kind of go through it faster. And then we'll do one problem that's completely different. I don't even know why this was thrown in the homework, but it is, so there's just going to be one of these last type of problems. But before we do that, let's go ahead and do one more of the harder type problems. So it's going to be a 5th root of 128 x to the 14th z to the 5th. Okay, so again, the index for us, I'm just going to write it right here, is a 5. Okay, so I got to think of numbers that have a 5th power to it that kind of give me 128. And I know this takes time and it takes practice. A calculator is really helpful with this. Okay, so we have a 5th root. Now 128, I know is 64 times 2. Yeah, 64 times 2. So that's something that I kind of already understand. And actually, you know what? It's actually 32 times 4. That works better because 2 to the 5th is 32. Now, x to the 14th, I can write that as x to the 5th. So x to the 5th, sorry, not x to the 5th, x squared to the 5th power, that's x to the 10th, and then times x to the 4th. So I have x to the 4th right there. And then after that, I just write z to the 5th because that already has a 5th power. So if I can, what I'm going to do is I'm going to rewrite 32 as 2 to the 5th. So this is going to be 5th root 2 to the 5th times 4 x squared to the 5th x to the 4th z to the 5th. Okay, now let me highlight my indices here. My index with this power, and that power. The ones that I highlighted, they are coming out. The ones that I didn't, they're stuck. Okay, this is stuck in there, this is stuck in there. So here we go. We're going to write a 2 outside, an x squared, and a z, because these are the things that get to leave because they have the 5th power. The rest of it gets to stay inside. So it's going to be a 5th root of 4x to the fourth. And that would be your answer for that one. So here we go. There's that solution. Now, there's one more problem that they gave us to try. So I'm going to put example number 2. And this is an evaluate type of problem. Okay, so evaluate. And they say given f of x equal to the absolute value of x plus 3x squared and g of x equal to negative 2 plus the square root of 4 minus x, find, they say, f of 2 and g of negative 5. In other words, they want us to plug in a 2 into the f function and a negative 5 into the g function. So let's go ahead and do that. Okay, so f of 2 means that I plug in a 2 where the x's are, okay, 3 times 2 squared in the f of x function. So there you go. So that's absolute value of 2 plus 3 times 4. That's absolute value of 2 plus 12. So again, that's the absolute value of 14, and the absolute value of 14 is just 14. So there you go. This is not a tough problem to do. I'm not even sure why this is in this section, but maybe because of g of x, it has radicals in there. Let's look at g of x. Okay, so for g of x, they want us to find g of negative 5. So that's negative 2 plus the square root of 4 minus negative 5. Okay, so let's continue to simplify. That's negative 2 square root of 4 plus 5. That's negative 2 plus the square root of 9. And we know the square root of 9 is 3. And negative 2 plus 3 is equal to 1. So hopefully this lesson is helpful for you guys when you guys do the ALEKS problems. If not, call your or message your teacher, tell them, hey, well, we need some help with this, we need help doing these problems. That way at least you guys get an idea of how to do it. If you need more explanation, more help, please let us know. All right, have a good day.